I guess we're going to get started since I think it's supposed to start at 11:35. And if anyone wants to show up, they can just trickle in. The first few slides are not that exciting anyways. Sorry, everyone that got here early. So yeah, this is extending Spark ML. In Spark, we can only do this in Scala right now, but I figure for a Scala conference, I don't have to apologize that much. If there's any secret Python users hanging out in the room, I'm sorry, it doesn't work in Python yet, for reasons which we can talk about over at least 2 shots of whiskey. So I'm Holden. My preferred pronouns are she or her. It's tattooed on my wrist in case you forget, so try and not forget. And I'm a principal software engineer at IBM Spark Technology Center in San Francisco. It's really nice. They pay me to work on open source software, and I'm sure they get some value from it, but I'm mostly excited I get to write code. And I'm a Spark committer as of this January, which is really exciting to me because it means I can merge my own code some of the times without people like necessarily noticing, and I can do evil things. But of course, evil things in the Apache way. So always on brand. Previously, I've been at a bunch of other companies besides IBM working on sort of similar problems. I've worked with Spark in many of them, but also like Google and Foursquare, we use different tools and stuff like that. If you want to follow me on Twitter for a Canadian who's kind of really confused with why she decided to live in America, you can find me. It's at Holden Karau. I do occasionally tweet about computers, but right now it's mostly sadness. I've got some slides. They're on SlideShare. The slides from today's talk will probably go on SlideShare unless I get really drunk, in which case they'll go on SlideShare when someone reminds me. If we want to pretend to be business professionals, you can find me on LinkedIn and tell me what it's for. And GitHub has the code examples from this talk. The rest of them are in this other GitHub repo that I have, but whatever. That's pretty fun. And like, I'm trans, I'm queer, I'm Canadian, and I consider myself a part of the leather community. In fact, I'm going to a leather conference right after this conference. And I mean, that's not super relevant for writing software, but I feel like a lot of people maybe don't know other people like me who are visible about who they are, and like, hello. We're not maybe as scary as television sometimes implies, you know. I make the same stupid Scala mistakes that you make. I don't have any secret powers from these things. But yeah. And I'm also on an H-1B visa, which feels amazing after the executive order. Anyways, that slide is not necessarily endorsed by my employer, et cetera, but yeah, so my employer is amazing. I love them. They give me money. And not only do they give me money, they give about 50 other developers money to work on Spark and Spark-related tools like SystemML and Apache Tori. And it's a lot of fun. We hang out in San Francisco and write open source code. We have this graph. It goes up and to the right. This graph is why I still get paid, so that graph will keep going up and to the right for a long time, or at least I hope so. So we make a lot of contributions to Spark. And if you're ever considering buying something from IBM, I don't know what it is we sell, but please do buy it. Our last quarter was not that amazing, I think, is what the press said, so please buy mainframes or services. Yeah. Right. Okay. So you all laughed at my corny jokes. So you're clearly nice people. So we don't have to go over that assumption. If you object to pictures of cats, this talk is not for you. I'm sorry about that. How many people have actively worked with Apache Spark? Yay! Okay. And now for those of you that didn't raise your hand, if you are confident in raising your hand to say that you have not worked with Spark. Are you willing to raise your hand? Oh, wow. Okay, that's still a good percentage of people. That's pretty awesome. So we're going to cover some of the basics of Spark, and hopefully this will be enough to trick you into using Spark in your daily work. This might not be enough to actually make you use Spark into your daily work. For that, Paco has a really wonderful introduction video, and I have a book I would like everyone to buy several copies of. And who here is new to the Scala community? New to Scala? Yay! Hello! Okay, so if there's parts of the slides which don't make sense, stop me and we can explain them, and it's cool. Welcome to Scala. Happy friends. Okay, and yeah, I'm hoping everyone's here because I think machine learning is kind of cool. If you don't, it's probably going to be kind of boring, but whatever. We're going to talk about a bunch of stuff. Yay! I'm going to try and trick you into publishing your fancy new machine learning models on GitHub so I can steal them and use them, or collaborate with you. It's not stealing if it's Apache licensed. So for those people who are new to Spark, it's a general purpose distributed system. It's written in Scala. It has a really nice API. Even for the Python users, we have a really nice API. We have an R API, but really and nice are not adjectives I would describe for our API just yet, but we're working on it. So if you're like interested in working in Spark, but not everyone in your company is like ready to use Scala, you can still totally bring Spark, and it's a great Trojan horse for convincing your employer to use Scala, because you can use it in Python, but you can do so much more in Scala, and it's a good way of tricking people into using Scala. It's really active, an Apache project. A lot of people find it while they're waiting for their 8-hour MapReduce jobs to finish. And they're like, how can I make my MapReduce job faster? And then they find Spark, and they're like, I bet I can learn this by the time my MapReduce job is finished. And sometimes that's true. Not always, but at least sometimes. The other way people find it is they're like, why is Python running out of memory? And then they're like, oh, okay, I'll distribute my computing. Yeah. Spark datasets are also sometimes called Spark Dataframes in earlier versions of Spark. Spark has two sort of abstractions. We have this magical distributed collection called the resilient distributed dataset that you can pretend is a magical distributed collection until it stops working, and then you have to find out what the magic is. And datasets and data frames are similar. We can pretend they're this magical distributed collection that I can also run SQL expressions on top of until it stops working. And then we have to figure out what the details are. But for the purposes of today's talks, we can pretend that they're magical, happy expressions. And I can run, I'm sorry, this is in Python. I can run both things in this like little DSL that we have, and the DSL is the same for the most part between languages. Or we can specify lambda expressions or like arbitrary functions in Scala and run them over our distributed data. And it's awesome. It distributes both your data and the work that you're doing on your data across your cluster magically for you. That's pretty cool. So what is Spark machine learning? Spark machine learning pipelines essentially looked at scikit-learn and went, oh, wow, those people made a really good API. I'm going to try and steal as much of it as I can. And we didn't succeed in stealing all of it, which is very unfortunate, but we stole a lot of their good ideas. And so in Spark, our first attempt at machine learning was very much focused on just making like individual models. And you passed in this RDD, which was already cleaned up and had all of your data like nicely organized, and then you train your model on it, and you went away. But then it turns out that like that's not actually really how anyone does machine learning, right? Everyone who does not everyone, okay. Most people who do machine learning have messy data, right? Like our labels are kind of crappy. We've got a bunch of null columns. We have like maybe textual data in the middle of something for some reason. And so we need to spend a lot of time cleaning our data. And how we clean our data actually can really impact the later stages in our pipeline. And so Spark ML says like, hey, we're going to make this thing so that we can put together all of the things that you've been doing into a single pipeline, and then we can do training on your pipeline, and you don't have to worry about like doing a separate data cleaning phase. We can do this as an integrated component. And so that's kind of cool. The pipeline stages are sort of broken into two categories. There's estimators and transformers. And estimators are things which have to see some data first, so we have to train them. So machine learning models are estimators, but also things like a string indexer tends to be an estimator, because we want to make sure that we're indexing frequent strings to low numbers, or essentially we want to make sure we're not indexing two strings to the same number, right? We can clearly do like hashing, and if we do a hashing thing, that's clearly a transformer. It doesn't need to see any data first. We can just hash our inputs, and things are fun. And our tokenizer in this case is the high-quality space tokenizer, which works really well for English, and we're in North America, so I can pretend it works for all of the languages I've seen. If you're not from North America, the tokenizer needs a bit of extension, and you can make it work. But normally you can make a tokenizer, which is a transformer rather than an estimator. Yay! So we're going to build a stage together. We're going to say, like, I like Spark ML pipelines. I think they're really cool. I think I'm going to do my machine learning with them. But I want to feel like a badass, right? I don't want to just pull a bunch of components off the shelf. I want to add something new, and I want to do something cool. And I've managed to trick my boss into this by saying that I really need this special algorithm that isn't in Spark, and it's only going to take a month. And like at the 1 month mark, I'll tell my boss it's only 1 more month. And I can do that about 3 times before my project gets canceled. And in that 3 times, I can probably make something cool. If you don't have that time, you can just make a transformer. You just tell your boss you need to do some special data cleaning, and it'll just take you a week. But you can fit it into Spark's ML pipelines. And there's a whole bunch of things that are actually already available. So there's a chance that you might not actually need to make your own pipeline stage, right? Like, we've got decision trees. We have we have logistic regression because, yay, fitting lines to things. It's like it's what most people want them when they ask for a machine learning engineer. And we've got like ALS, which kind of works. Our ALS implementation has been improving substantially. And in addition to sort of the classic machine learning models inside of Spark, there's Spark packages where people who have made their own machine learning models, people who have tricked their boss into giving them 3 months to write their code, have gone there and added their own stuff. But you're going to add your awesome Foo-Bazinator, and we're going to make some really fun code together. So what is our Foo-Bazinator going to look like? We're going to start on our adventure. And Miffy, I almost lost Miffy right before the talk, and I was really sad and stressed out. But I found Miffy, and I feel like that's a good omen for this talk. You might not agree, but it's OK. So Miffy is going on an adventure to extend Spark machine learning. She doesn't have opposable thumbs, so it's going to take a little bit of time with the single typing, but we're going to get there. And we're going to start with just a transformer because Miffy doesn't have 5 fingers on each hand. She's only got the hands. But we're going to build a transformer, and this is going to be really simple. And it's a good first step in extending Spark ML because our estimators are going to return transformers. And to make a transformer work, we need to provide this thing called transform schema. And what transform schema is used to do is to validate that our input schema is reasonable. Now, this is a Scala conference, so you're probably like, Holden, why aren't you using types? And that's like a really good question. And it's not for me. But unfortunately, we have to do this at runtime because we pass around these Dataframe objects where we don't have the types constrained on them. And instead of having like compile time type checking, we're like, well, at least we shouldn't fail in the middle of an 8-hour machine learning job. We should fail at the start of the 8-hour machine learning job if we can. So when the machine learning pipeline starts up running, we check that our inputs are valid. And we're going to make it so that our pipelines are configurable, and so our pipeline stages are configurable so that I can do parameter grid searches across them, because I did not do very well in statistics in school. They actually, they let me pass because they lost my final exam, which was like, yeah! I think I did like well on the final exam, but at this point, who really knows? So I'm going to trust the computer to do a parameter grid search more than I'm going to trust myself to pick the right L1 regularization parameter for my linear regression model. So our simplest transformer is word count. You might have thought you were going to escape the word count example. This isn't going to be a proper word count, but it's going to be a really basic word count, and we're just going to count the number of words that I've got in some random thing in the input. These 2 random functions we have to provide, they're not really all that important. Default copy really should have just been the base instance of copy, but it's not, and we don't want to break binary compatibility. So every time you make a new stage, you need this boilerplate. It's a lot of fun. Oh yeah, and these transformers are not from the mighty Morphin. Yeah, they're not that kind of transformers. So verifying that our input schema is reasonable, it's pretty basic. What we need to do is make sure that like whatever fields we were expecting to be present are present. And then we also need to update the result so that the downstream pipeline stages can consume our fields, right? Because if we didn't add whatever fields we were returning to it, the next stage in the pipeline that might use it wouldn't see it, and it wouldn't know that it's actually safe to run. And so yeah, transform schema is used to verify that things should work, and that works about as well as everything where I go should. Sometimes it fails, but you know, whatever. It stops enough errors that it's worth doing this early on. So how do we actually like make the pipeline stage do something? This isn't really all that exciting. I've got a word count that's just going to count the number of words. It's not even going to give me the like words and their counts. But we just call transform, and I define my UDF, and I do whatever I want, right? And our UDF could actually be much more complicated, and we'll look at one of those in a little bit. But this is clearly, we don't have to train our word count model. It's going to be able to count the words without training, so we can just directly implement this transform function. And then we need to make it configurable, it turns out. Like, people, for some reason, don't want to rename their data fields into happy pandas as an input column, so we make it so that it's configurable. And we have to use this parameter, well, we don't have to, but we should use this parameter mechanism from inside of Spark, because when we use this parameter mechanism from inside of Spark, the meta algorithms that Spark has are able to work on our parameters. And this is pretty nice. If you're like wondering what kind of knobs you should provide on your new machine learning algorithm, you can go look at this file called sharedparams.scala inside of Spark and see what the common parameters are that the different models are exporting. And cross-validation, yay, it automatically fits our stuff. It even works in Python. But I clearly gave you the Java class path, so whatever. And here's an example. Mostly, you know, it's not that hard to do, but here I'm only tuning on one parameter, but we could tune on 5 parameters. The only problem is I would have like one of those exponential curves with the amount of time it was going to take. And so that gets a little sad at some point. But if you make your machine learning models this way, people like me who aren't very good at statistics can pretend that we are, and I would really appreciate that. And you can make it so that I can use my parameter grid and do a search. And I can search across multiple stages at the same time. And if you do this, please reserve a test set beforehand. Otherwise, your results are kind of meaningless. Yeah. So that's not all that exciting. That's just making an instance that counts the number of words. We actually want to provide like a machine learning model. I want to go off for 3 months after I told my boss it was going to be 1 month and make a new fancy machine learning model. And I assume you all do too. So we're gonna make one of those. And cats love it, yay! So the difference is, instead of providing a transform function, what we need to provide is a fit function. In this case, I'm just making a simple string indexer, but essentially, if you were doing naive Bayes or something, like you would do your counts here. If you were doing something with a gradient descent algorithm, you would do your gradient descent to do your search for the right parameters inside of your fit function here. And then at the end, you return a model, and your model is going to be like the transformers that we just looked at. Oh, that slide is repeated twice, sorry. So the one thing is getting our input columns, getting the variables that we define with the parameters. We just use this $sign input call syntax. If you're outside of the input stage and for some reason you want to look at what the parameters were that were configured on the stage, like maybe you've written it out to disk or you're getting ready to, you can use our friendly Java bean-like functions, get input call, yay. And we can pretend like we're writing Java 1.2. Okay, no one's excited. And our friend the transformer is back. So our simple indexer here is this transformer. We construct it. The things that we're passing into it, they're like configurations, but since it's not something that the user would set or not something that they would doing over a parameter search, we just have it as standard constructor parameters rather than special Spark parameters. And then we have our fancy transform function. And it's not all that fancy, but it just does its thing. Yay. So we left out transform schema in this instance of it. And we still need transform schema, even though we're not going to be doing the checking beforehand to make sure that pipeline is going to succeed. But we still have to provide transform schema in any instance of this just because it's part of the signature and it's still used. You can use a classifier or estimator based class and they'll provide a transform schema. You have to provide a slightly different transform function and some extra type information and they do it for us. And so we're going to build a classifier instead. Yay, we're going to build a really simple naive Bayes classifier because word count was kind of boring and everyone looks like they're falling asleep. Even Boo is getting a little tired. It's okay, Boo. So we're going to make this. We specify that our input type is going to be some vectors. We're going to return a simple naive Bayes model. It's going to be pretty amazing. Our train function has a lot of ... dots inside of it because I'm lazy, but we'll actually expand those ... dots for people that really want to look inside of the ... dots. And so here we figure out the number of features it's being input. So the input to most Spark machine learning models is a vector in that your data frame has a features column and your features column will normally be a vector. And this is produced using something called the vector assembler. But it's just a bunch of doubles. And so we can go in there and pull this out. Group by key normally is the devil, but in this case it's not. Is it? No, it's not the devil here, because I'm in the happy dataset land. In datasets, group by key is safe. If you're in RDDs, group by key makes you very sad and your job fails. But since we're working on datasets, this is actually pretty awesome. And then I can go ahead and I can get my class counts, and then I can select the labels and features. And then I let go, and I do some, the comment ratio to like code is pretty all right. But we're going to figure out the number of documents as well and the number of classes, just because we're training a naive-based thing. And then we're going to go ahead and actually get our label counts. And this is just a really simple aggregate. You could probably write a much better aggregate, but this is just a really simple aggregate. And the important thing is, right, like we're doing all of these things in transformations on data frames. Like we're not going to collect the data back locally and do something with it. The only exception is if you were doing something like gradient descent, you would collect back sort of your training offsets and then you would do another iteration. But since this is really nice and basic and deterministic, we're fine. Yay, more code on slides. Not that exciting. There's probably even typos in this code. That it's actually the correct one is in my GitHub, so you should look at that one rather than paying too much attention to this. So what does using the Basetrade get us? So this time we used a classifier trait. It gets us free schema validation. It gave us some free parameters. We didn't have to specify what our input column was. The transform function calls our trains function. That's the wrong way around, but whatever. And it gives users a better understanding of what to expect, right? And that's the main thing. If you are going to actually go out and build something like an iterative machine learning algorithm, there's this like sort of sneaky part inside of datasets, which is really sad. And this is that datasets and iterative algorithms are like oil and water right now. And so if you look inside of any of the Spark ML models, which are actually doing iterative training, the first thing that they do is they take the data and they switch it into an RDD, and then they cache it. And you're going to want to do the same thing too. And this is just because the dataset APIs are really nice and wonderful, but the dataset optimizer gets kind of overloaded when it gets a lot of really identical looking subqueries, and they go on for too long. But the DAG optimizer is really basic, and it doesn't get overloaded by that, and so we just switch to using RDDs for now. And it works out much better. Ooh, sorry. And I am well aware that this is the talk that leads right into lunch. And Boo has found some lunch food and would not want to keep anyone from their lunch. So we'll wrap up without too much excitement. But what can we do now that we've made our ML pipeline model? You should put it in an ML pipeline. You can even actually try putting it in and comparing it to an existing Spark ML pipeline, an existing Spark ML stage. So if you've built your like basic Spark ML linear regression thing, and then you've made your new fancy like all of your business logic whatever stage, and you slot that one in, you should make sure it actually performs better than the default ones, because a lot of the times the things that we spend 3 months on don't work as expected. We can do hyperparameter tuning, yay. If we wanted to say like use our model for some reason, we could actually implement save and export. ML reader and ML writer give us sort of the basics for this, but you're probably just going to want to write your own custom export logic, because Spark's ML formats are very exciting with a lot of opportunities for future improvement. Because, yeah, Parquet is an amazing format for storing coefficients. And the serving side, you can kind of do serving inside of Spark, but you really, really shouldn't. People keep trying to build real-time serving layers with Spark, and it's not a good idea. I even had beer with someone last night who was trying to do that. Because of business reasons, I believe would be a good expression. And really what you want to do is you want to persist it out to some other system. So if you can save it in PMML or whatever format you want, you can do that. And yay, okay, so you've made your ML model. It actually worked pretty well. You put it up on GitHub because you're a nice person. But now you can publish it to Maven Central, yay! And then we can put it on sparkpackages.org, where you can look and find the other ML pipeline models who are made by people who were like, yeah, how hard can it be? And yeah, it's pretty fun. If you like Python people, you can look at how we expose the ML models in Python for Spark. It's mostly done using this thing called Py4j, which is capable of summoning Cthulhu if used incorrectly, so please test your Python bindings. There are no types to help you out and keep you safe. So if you want to support Python users, that's great. I love you, but please, please test your Python code. I mean, test your Scala code too, but like, I assume we're all good Scala developers here already. And there's a bunch of resources. So if like those 5 slides with code on it wasn't like the most exciting thing in your world, that's okay. I have an example repo. It has some sample models in there. They range from the really simple word count thing that we looked at to like this really simple naive Bayes thing that we also looked at. If you want to see like how the iterative algorithms are implemented inside of Spark, because you're interested in doing something with like a gradient descent model, you can look inside of Spark itself. They use a lot of internal APIs naturally, but the code is nice and public, and you can just rewrite the parts that are calling the internal APIs when you're thinking about it. I also have an O'Reilly blog post about it. Might be good, I don't know. Probably the other resources are more directly useful to you. And there's some Spark books, yay. Most of these Spark books are written by me. I think that's true, yes. But not all of them, so I don't receive royalties for all of these books, but I will try and get you to buy the one where I receive the most royalties, because I like coffee, and living in San Francisco is really, really fucking expensive. One of the books that I didn't write is called Learning PySpark. If you have Python friends and you're looking to convert them to the dark side, you can give them Learning PySpark, get them hooked on Spark, and then show up 3 months later and be like, by the way, Scala will make your code so much faster. Or, not that you should convert your friends to the dark side for cookies. But you can buy this book, yay! It's available in early release from O'Reilly, which means that you can give me money for something that doesn't exist. And I like things that I can sell that don't exist, because it's really hard to return something that doesn't exist. Actually, it's very easy to return something that doesn't exist, unfortunately. But that should not stop you from buying it, and especially if you have pets. Pets really love the Amazon boxes that books come in. So if you have a corporate expense account, I think it is a great time to buy several copies of this book for everyone that you know. Also, like the IBM compliance training said that I'm no longer allowed to accept $20 bills inside of brown envelopes. And so instead, if you buy this book, I don't get a $20 bill, but I do get like $1 or something like that from O'Reilly. And so like that can be a way of not bribing me or whatever those words are. But yeah, you can give me money this way. And I've got some other talks. If anyone's is anyone from San Francisco? Yay! Okay, so there's DataEngConf next week in San Francisco. I'll be talking about how to use data frames. So if like this talk was like, I don't know what these data frames are, then like you can come to next week's talk and learn about data frames. If anyone's looking for an excuse to visit Barcelona or London or Israel or Copenhagen or, I mean San Francisco, I mean, you can come and join me in these places and tell your boss that it's very important that you go see this talk. And I will totally back you up on that. And then we both win. Because your boss thinks that I know what I'm doing, and you are clearly an industry leader as well for needing to go to these fancy places. Okay, so that's pretty much it. Okay, thanks, bye. I figured I would leave 10 minutes for questions if anyone has questions. If you don't, I would really love your feedback on what you're doing to test your Spark applications. And if the answer is I'm not testing my Spark applications, I would really like to know where you work so I can short your company's shares. But more realistically, I really am interested in knowing what people are doing to test their distributed systems so that I can try and make better tools for people. Or does anyone have any questions about extending Spark machine learning models? Coffee shops in San Francisco, I can also answer questions on. And Boo can answer questions on dog treats. And Miffy knows a lot about flowers. Or do we just go get lunch early? Okay, it sounds like Team Lunch is winning. So thank you all for coming. I hope this was at least somewhat useful. But thanks.